Yeah, welcome you all for another beautiful presentation on bipolar junction transistors. In simple way, we can call it as BJTs, that is bipolar junction transistors. And this is the lecture number 8. We are discussing about the BJTs. If you recall our previous presentation on BJTs, we have seen the physical representation of NPN transistor as well as PNP transistor, and then the electrical equivalent, okay, of NPN and PNP. We have seen in previous presentation that so the basic physical representation of NPN transistors, right? I think you have. So always remember that the middle portion, this is N, this is P, this is N for NPN transistor. So remember that. So this terminal is emitter terminal and the middle one is absolutely base, and then this right portion is called as collector terminal, right? So this is particular N-type material. So this is called heavily doped. Remember that this is what heavily doped actually. This is heavily doped, whereas the middle one, this is the base, actually base terminal is lightly doped, whereas the collector this particular N is moderately doped. This is the physical representation of NPN transistor. And suppose if you write for PNP also same, in place of N you just write P N, okay, PNP, that's it. Okay, everything remains the same. The representation of the terminals is same as emitter, base, and then collector. Clear? So basically the emitter terminal injects or emits the electrons basically to the base terminal, and this particular base terminal passes those electrons to the collector, or the collector terminal collects the electron from this base. That is why the name collector, actually it collects the electrons from the base actually. This is what happens internally in the transistor, right? And similarly we have seen in previous presentation that the electrical equivalent of the transistor, as you know that this is what the electrical equivalent. So this is what your base terminal actually, and this is what your emitter, right? This is what your collector actually. This is the base terminal and this is the emitter terminal, this is the collector terminal, right? And we have seen the flow of the current also, the direction of the currents also, because as we have three terminals in the transistor, so in the base the current is base current actually, I suffix B is the base current, and the current in the collector terminal is called as the collector terminal, I suffix C, whereas the current in the emitter terminal is nothing but emitter current, I suffix E. And the arrow mark indicates the flow of current as it is going forward or outward direction, and you can simply show the current direction in this way. As it is going outward, definitely the remaining two currents goes inside actually, like this forward direction, because as far as your KCL, Kirchhoff current law is concerned, once this is particular, if you consider it as a node, then outgoing current is equal to sum of the incoming currents. Therefore IB and IC, the current directions for IB and IC must be towards the node, as well as this is the leaving current, these two are the entering current. So in this way you can say that your emitter current IA is equal to, it is the sum of base current and then collector current. Okay, this is the current relationship for a transistor, right? So now we see that a little bit extension of our previous presentation, and we have seen that as the transistor will have three terminals, that is base and then collector and then the emitter. So this particular transistor will be used in three configurations actually, right? So as the transistor, so remember that, so I will draw again. So this is the basic electrical equivalent of a transistor or NPN transistor. This is the NPN transistor. So this is the base terminal and this is the your collector terminal. This is what your emitter terminal, right? As the transistor sorry, as the transistor has three terminals, right? So this transistor can be used as in three configuration. It can be used in three configurations, right? So one is the configurations. You can write configurations. So what are the configurations? What are the configurations? Configurations. So as the transistor has three terminals, so it can be used in three configuration. One is common base configuration. You can write common base. What is that? Common base, or simply you can write CB. Okay, CB configuration. And the second one is the common emitter. Right? The second one is the common emitter. That is, in short, you can write CE configuration. And the third one is common collector. Right? The common collector, CC configuration. So these transistor can be configured in any of these three configurations. Either you can be you can connect to this in common base configuration, or otherwise common emitter configuration, common collector configuration, right? And what is the name of this common? The common in three configuration, you can see that this is the one common word, that is common, common base, common, and then common, and then common. What do you mean by common? Common is nothing but, in common base configuration, common base is nothing but the base terminal. The base terminal put it as a common. Actually, the base terminal can be kept as common with respect to remaining two terminals. That is the meaning of it. The base terminal will be kept as common with respect to the remaining two terminals. In other way, the base terminal can be put as zero potential, at ground potential. Common is nothing but, so that particular terminal is kept at zero potential, means like that base terminal must be kept at zero potential, ground potential. So the voltage is 0 volts there. So the base terminal should be kept at zero potential, right? That is the meaning of it. Therefore, so in common base, your base terminal will be common. Similarly, come to the second one, the common emitter. Common emitter, in common emitter configuration, now the emitter terminal is kept common actually. So this is kept as a common terminal with respect to remaining two terminals. What are the remaining two? If you put emitter as a common, remaining two are base and then collector. So one of the terminal can be act as input terminal, whereas the another terminal will be taken as output terminal. So if you see common base, so if you put that base terminal as a common, then one terminal in the remaining two terminals, one terminal will be act as input terminal, whereas the another terminal will be act as output terminal, right? Means that what, with respect to this base terminal, we have to apply the input at one end, and you have to take the output at the other end basically, right? And similarly, in common collector also, in common collector, your collector terminal can be put as a common with respect to remaining two terminals, right? So common is nothing but, so that particular terminal, either base or emitter or collector, can be put at zero potential with respect to remaining two terminal. That is the meaning of it actually, right? This is about the configurations actually. Now what is the main application of a transistor? We have discussed already in the previous presentation. What is our main application of a transistor? The main application of a transistor is that the transistor can be used as an amplifier, right? The transistor can be used as an amplifier. So that is the main purpose of a transistor actually, right? Well, so now let us see that, see for example, so this is the, let us simply say that, for example, for your convenient, I will explain this particular electrical equivalent, okay, by taking emitter as a common. Let us see for a small for your this thing, let us put this emitter as a ground. Let us say, if we put this emitter terminal as a ground, then it is called as a common emitter configuration. common emitter configuration. So I am putting this emitter as a common, means that should kept at zero potential with respect to remaining two terminals actually, right? That can be shown like this actually. Then what are the remaining two terminal? If you put emitter at ground, what are the remaining two? Base and then collector. Remember that. So in common emitter, if you put emitter as a ground, then definitely your base terminal must be input terminal. Means that what? If you observe that, so base to emitter, this is one junction actually. This is junction 1. Remember that. This is what J1 you can say. This is junction 1, right? Because if you see the physical construction, here, right? So let us say P, or you can say N, NPN transistor. Okay, so the middle one is the base, and this is what your emitter actually, and this is what your collector terminal, right? So emitter, base, collector. If you see in between N and P, there is one line. What is this actually? You know, this is junction 1 actually. This is what your junction 1. So in between emitter to base, you have one junction. This is what junction 1. You have one junction between emitter to base. That is what this actually. Base to emitter, in between these two terminal, you have one junction actually, also called as input junction. This is you can call as input. What? Input junction. That junction you can call it input junction. Therefore, this is called the junction which is there internally between base to emitter. Base to emitter is called input junction. And now, again, if you see between this P and then N, right? Between P and N, you have this another line actually. This is called another junction. This is you can call J2. This is nothing but your output junction. This is what your output junction, right? Means that what? That is between base to collector. This is between base to collector. Therefore, right? Is it not? Base to, okay? That is what this is the second one basically. And that can be taken as like this basically. That is shown between collector to base actually. So this is input junction, whereas collector to base basically. Collector to base. But that is the, in physical representation you can show like that, means that collector to base, this is this thing. But however, if you see electrical, the output will be taken at collector only, means like this. At collector terminal you will taken as output actually. So this is what your output. Basically in electrical equivalent you show your output like this. So at collector with respect to emitter, collector with respect to emitter you have to take the output, whereas base to emitter you have to apply the input here. Therefore what I mean to say is that, so this is what your input junction, whereas collector to emitter, this is what the other, you can consider like this. So this is what your output actually. Clear? Now very important point here to remember is that, so our objective is to put or to operate this transistor as an amplifier. So obviously you have input junction here and you will have another output junction. Okay, so you should apply the input between base to emitter. You must apply your input here, right? You must apply your input here between base to emitter, and in between this collector to emitter you have to take your output actually. You have to measure your output. You will obtain your output here. Then definitely in between these two, how the input should be given. So we have to connect the DC power supplies here. DC power supplies. Okay, how the power supply shall be given here. How this power supply shall be given at the input side as well as between collector to emitter. How the power supplies or the DC voltages, how these DC voltages will be connected. That is very important. Remember that one important thing to note down is that is input bias. Your input junction means this must be, it must be forward biased. Your input junction must be forward biased. Your input junction must be forward biased, whereas your output junction must be reverse biased. Remember that, reverse biased. Okay, this is what your NPN basically. So N P, N transistor. Therefore, your emitter is N here, base is P, and then N is your collector. Your collector is also N here. Therefore, P is nothing but what actually? In P means majority are holes. Therefore, holes are nothing but holes are positively charged. Holes are positively charged, nothing but. So, you must put between base to emitter your VBE, nothing but your voltage is nothing but VBE. How that VBE shall be given here? So that must be forward biased. This input junction must be forward biased. That is nothing but between these two terminals. This is base actually. This is emitter actually. This is emitter terminal, common terminal. So in between these two, you must give your voltage like this, plus and then minus. This is nothing but your base to emitter voltage. Actually, you can show this VBB also, but absolutely this particular voltage is nothing but the voltage between base to emitter. Obviously, it is VBE only. So this is plus. Therefore, as your P is the P type is nothing but this P type will have majority or the holes. It is a positively charged. Therefore, P is nothing but plus only. So for this plus, if you connect the plus of the battery, plus terminal of the battery, external power supply, if you connect this plus connection of battery to the, then it will be forward biased actually. And similarly, so here between collector to emitter, this is your collector terminal, this is the emitter terminal. In between these two, so here N is nothing but electron. Electron is a negatively charged. So it is a negatively charged, therefore it is negative. Therefore, in order to put the output junction in reverse bias, so you must give this negative to again positive actually. So this must be positive again. Is it not? This must be positive. This is what? So opposite actually. So this is minus, then it will be plus. So if you connect, because plus to plus, same connection, if you give the same connection, then the junction will be forward biased. And if you give the opposite connection, means the N is negative actually. So for the negative, for it is a for N type, the majority carries as electrons. Electrons are the negatively charged. For the negatively charged electron, if you give the positive battery here, then the output junction will be reverse biased. Therefore, obviously, what is this actually? This power supply, it is collector to emitter, you can say. So collector to emitter, therefore VCE. Therefore, this is how the transistor should be connected. So now you can say that the input bias or the input junction, otherwise the input junction, whatever is there, it is a forward biased. It is a forward biased, whereas your output junction is a reverse biased. So this is output is a reverse biased, input is a forward biased. This is the very important condition to note down. If you connect the transistor in this way, then only your transistor will work as an amplifier. How the input-output junction shall be biased. However, I will tell you in the subsequent presentation that what is a biasing. That we will discuss in the next presentation actually, or next or after that, don't worry. Biasing, this is called biasing. Biasing is another excellent word to be used in transistors topic actually. Biasing is nothing but it is the method or it is a process of connecting the external power supplies in order to put or in order to keep the circuit in active position or in active condition, right? So likewise here if you see that VBE is the DC power supply, this DC power supply we have to connect externally. Similarly if you see VCE also DC power supply, VB are the DC power supply. There are two power supplies are there which are externally we are connecting to this simple circuit, transistor circuit, right? So the process of connecting these DC power supplies to the transistor circuit is called biasing. Biasing means you are putting the circuit in active condition by connecting these two power supplies, and thereby we will switch on this, and then automatically the power supply will the supply will go to the circuit and circuit will become on. That is what biasing in the sense, right? So this is what biasing voltages. So here VBE and VC are called as biasing voltages actually, right? So remember that. So the input junction shall be forward biased. whereas the output junction shall be reverse biased. Remember that. This is the very important condition. So in this condition only, your transistor will act as an amplifier. Okay, right. So say for example, if the both junctions means the input junction as well as the output junction, if both are forward biased, let us say what happens. Okay, here the input is, however, it is a forward biased actually. Now come to the second, this particular bias. It is a reverse biased now. Say for example, if I connect this output again in forward biased, if I connect the output junction in forward biased, what will happen? So if the input junction is forward biased and your output junction is also forward biased, if both are the forward biased, then the transistor will be in saturation mode. It goes into saturation mode actually. It is called saturation, right? And similarly, in the third case is that, so if I connect the power supply at the input junction reverse bias, right, I will put the output in reverse bias itself, I will keep the output junction in reverse bias itself, and if I connect the input junction in reverse bias, then both are the reverse bias actually. If I connect these two power supplies in reverse bias condition, what happens? It will be cut off condition, that is called cut off state. So the transistor will go, there is a chance for transistor to operate in three states. One is the active state, active region, you can say the transistor will work in active region. Second is the saturation region. Third, it is the cutoff region, right? One is the active region, right? One is the active region, you can say. One is the active region of operation. One is the active region. So for active region of operation, input junction must be forward biased, output junction must be reverse biased, right? Remember that. In active region only, the transistor will work as an amplifier. So for okay, remember that. So in active region of operation only, the transistor will work as an amplifier. And coming to the second, so what is the saturation? Next is the saturation region. Saturation. What is the saturation region? If saturation region is nothing but both the junctions are forward biased, both input and output are forward biased, then that is called saturation. And what is the third region of operation? Cut off region. So third one is the cut off region. So in this region, both the junctions are under reverse biased condition, right? Therefore, so the very important thing in today's presentation is that, so for a transistor to be acts as an amplifier, how the input and output junction shall be kept. The input junction must be kept under forward biased, whereas the output junction must be kept under reverse biased. That is the very, very standard point that to note down. Okay, so that is a very important application of this transistor. I think we'll finish off this presentation here, and I think I hope that you understood well. And okay, we will continue the next the subsequent continuation of this actually. So by applying these particular, we will see the input characteristics, nothing but it is the graph actually, voltage to current. Okay, so we will consider the input voltage and then input current actually. So here, as it is the input junction, the base current, the current flows in base terminal is nothing but our input current basically. So this is what your base current IB actually. However, this is your IE is the emitter current, because as we have grounded this particular, therefore there is no use of the emitter current, right? There is no use of the emitter current actually. And so this is what the flow of current actually IC, because it flows like this. Okay, your base current flows like this, emitter current flows like this. Therefore, so as the emitter is grounded, then IB considers as input, therefore the current flows through base terminal is called as input current. Similarly, this is collector will be taken as output, therefore the collector current is the output current, right? So these are the input current and then output current, right? So for any amplifier circuit, normally there are 4 parameters to be considered very importantly. Those are called, the first one is input impedance. This we will see in the next presentation actually. Input impedance, right? That is denoted by capital R suffix I. I stands for input. And the second one is the output impedance. This is the output impedance, right? Output impedance R suffix naught. And the third one is voltage gain. Actually, it is called voltage gain. Gain is represented by capital A, and as it is voltage, therefore suffix B we will write. So A stands for voltage gain. So A stands for gain. Actually, A is the representation of a gain. As it is a voltage gain, we will write suffix B, voltage gain. And the fourth one is current gain. The fourth is the current gain. So gain as A, as it is a current, A suffix I. Therefore, these are the four important parameters need to be considered for any amplifier circuit actually. So we will focus these two on these four parameters while selecting any transistor as an amplifier, right? So how is its input impedance? How is its output impedance? How is its voltage gain? How is its current gain? So we will think about and we will consider these four parameters. If these four must be reasonable, these four parameters must be reasonable for selecting particular transistor as an amplifier, right? They must be very good values actually. Therefore, here, right, this is what the basic circuit of a CE amplifier. You can say it is a CE configuration, as we have grounded as E as emitter, grounded. Therefore, it is called as a common emitter amplifier also, because in this case we have connected as forward bias, the input junction connected in forward biased and output is connected in reverse biased. Therefore, now it is acts as an amplifier circuit. Therefore, it is nothing but a common emitter amplifier. It is nothing but a common emitter amplifier, right? And we will see some more very important, the further extension of this in the next presentation. Okay, and I request you all that to give your comments, valuable feedbacks, and don't forget to share to your friends. And okay, right. So we will meet in the subsequent presentation. Right. Have a nice day.